Today we will start discussing about one more type of problem, that is trapping rainwater. That is right, trapping rainwater. Now, have you ever come across with this example, trapping rainwater? This is a quite repetitive example. Okay, it's a quite repetitive example which comes in the interviews. This will also help you to understand the two-pointer techniques, right, in a better way. So let's write down the name of the question: trapping rain water. Trapping rain water problem. Okay. Now, right, let's understand what is that trapping rainwater problem. Okay. Now let's understand what is that trapping rainwater problem is. See, I've created one image here. I've created one image. I'll just copy that. Okay, I need to select it again. Okay, so we'll consider this example here. Okay, we will consider this example here, trapping rainwater problem. Now let us say, right, let us say we have an array with elements like these. We have an array with these elements there: 2, 1, 5, 3, 1, 0, and 4. These are the array elements. Now, right, you need to understand here, right, how much of water can be trapped in these places, right? How much of water can be trapped in these, right, places. Now we will use these numbers, right, as the wall height of the wall. We will use these numbers as height of the wall, right? We will use these numbers as height of a wall. Okay, so height of wall, height of wall. Okay, now, right, let's concentrate on the area, other area. Okay, right, okay, this is the area where the water is trapped. This is the area where water is trapped. Okay, this is the area water is trapped. Now the question comes is, right, so these lines are, right, water. Okay, and these colored boxes are wall. These colored boxes are wall. Okay, now the question says that how much of rainwater can we trap in this place, right? How much of water can we trap in this place? Now you can see that, right, in this place, in the first place, how much of water can be trapped? 1, correct? Now look at this part, right? Here also we can trap 1, right? And here you can see that you can trap 1, 2, and 3, then plus 4. So total of, right, how much of water we can trap? We can trap 4, sorry, total of 9, right, amount of water can be trapped. 9 blocks of water can be trapped. So this is the task given to you. If they give you an array, you need to find out how much of water can be trapped, right, in these walls, right? water trapped. Okay, water trapped is 9. Are you clear about the question? So the entire question is all about what? Right? How much water can be trapped? Right? If any water, if you take the leftmost wall, you cannot trap more water than this height. Any water which is on top of this, it will fall down. Similarly, on the right side, any water which is on above this height level, that water will fall down. Correct? So you cannot count for the left wall and right wall. Whatever water can be trapped within that, that needs to be right found. Okay. Now I'll create a one more copy of this. Okay, I'll just keep it below. Okay, how do we solve this problem? Right, let's understand the very basic method. Let's understand the very basic method or name method, what we call it as name method. Right, basic method, basic method. Okay, so or it is also called as name method. Right, basic logic to solve this problem. So let us understand, right? Let us understand the steps, right? What are the right steps involved in solving this example, right? So basic is, so what we need to do here, let's write down the steps. So the first step is, right, traverse, right, traverse every array element, traverse every array element. Okay, traverse every array element, right, and find the highest bar on left and right side. Right, find the highest bars on the left and right side. Right, now after this what you have to do is take the smaller height, take the smaller height, right, take the smaller height of 2. Right, then once you take the smaller height, what is the next step? Right, so the between difference between the smaller height and current element height, right, will tell us the amount of water can be trapped. Right, okay, let's understand this one by one. So first of all, so traverse every element, right? So while traversing, you need to traverse it from the element 1, right? You cannot traverse from the first element. You need to start traversing from the, right? You need to start traversing from the second element, because this is the wall. This is the wall where I cannot go beyond that. Okay, these are the boundaries, so you should skip them. So traverse from the second element till the last but one element, till the last but one element, because these are boundaries, these are boundaries, right? So you need to find it within that. So traversing will happen from 1 to n minus 2. It will happen till n minus 2. Okay, now for every element, take the first element, right? This is the current element I have, 1. Okay, find the smallest, right, find the highest bar on the left side. Which is the highest bar on the left side here? Right, which is 2. The highest bar on the left side is, right, highest bar on the left side is 2. Now what is the highest bar on the right side? What is the highest bar on the right side of that? Which is 5. The biggest one is 5. So right is equal to 5. Now consider only the smallest. You cannot take the bigger one because I cannot keep water here. So I need to consider only the smallest height. I need to consider only the smallest. Now take the smaller height. What is the smaller height? Smaller height is 2. And find the difference between the smaller height and, right, the current element height. What is the current element height? It is 1. So once you take the difference of this, this is the amount of water that can be trapped for that current element. This is the amount of water that can be trapped, right, for current element. Are you understanding this? Is that clear? So what we have done, I'll repeat the step again. First, traverse the entire array starting from second element till the last but one element. You need to traverse from the second element, right, and till the last but one element, because the first and last extreme elements are, right, boundaries, right. So you need to calculate only the water that can be trapped within those walls, right. Now we will consider all of them as walls. Now what we have to do is take the, right, once you go for every element, second element take the second element, which is 1. Okay, find the, right, highest bar on the left side of that element, which is 2. Highest bar on the left side is 2, and the highest bar on the right side is 5. Now, out of these two, select the smallest one. Out of these two, select the smallest one and subtract the current height. And the value what you get will be the amount of water that can be trapped. Will be the amount of water that can be trapped for the current element. Okay, are you clear on that? Now similarly, this is the first one. Now let's start doing it for the second element. Let's start doing it for the next element. So the next element is what? 5, right? So on the left side, so current element is 5. So then on the left side there is no highest bar. Highest bar will always remain as 5 only. Highest bar will remain as 5, and on the right side the highest bar will be again 5. So out of these two, select any one, the smaller one. So out of these two, select any one, subtract, right, the current element. This is your current element. So subtract the current element, and the amount of water that you can trap is 0. The amount of water that we can trap is 0, right, because that is the highest bar. You can't store any water here, so that is the highest bar, right. Now what we will do is, right, let's repeat it for the next element. So what is the next element? Next element is, right, 3. Next element is 3. Now for the number 3, right, for the number 3, find out, right, for the number 3, okay, find out the highest bar on the left side. Highest bar on the left side is 5, and the highest bar on the right side is 4. Now out of these two, whichever is the smallest, right, out of these two, whichever is the smallest, right, consider that the smallest is 4 minus the current element is equal to This is the amount of water that can be trapped for the element 3. So you can see it here. You can see it here. For the current element 3, you can trap only these much one block of water. Okay. Similarly, you have to repeat for all, right? Similarly, you have to repeat for all, right? So can we start writing a code for this? Can we start writing a code for this if you have understood? Let's start with the code. Okay. First, we will write it in C language. Hash include stdio dot h int main opening bracket, right? So let's declare the array is equal to, right? We have taken the values as 2, 1, 5, 3, 1, 0, and 4. These are the values we have taken. Okay. Now the number of elements is equal to size of ARR divided by size of ARR of 0. This will give us the number of elements. Okay. Okay. Now once we get these two, the next job is we will call a function called as printf, right? Printf maximum water trapped is equal to percentage d double quote comma, right? We will call a function called as max water and pass the array and number of elements as a parameter. Pass the array and number of elements as a parameter to the function called as max water. So this function, right? This function max water returns the amount of water can be trapped in integer value. So the return type of this function is int and the function name is max water, and we have an array as a first parameter and the second parameter is the number of elements. Okay. So as I've told you that I need one variable to store the, right, I need to add all these values. I need to, whatever we are doing the job here, right, I need to add all of those values to get the final amount of water that can be trapped. For each element you calculate and add all of them, so that we will store it in result. We will store it in result. And then I need some more variables like I, okay, and we need j, and we need left, and we need right. Okay. So first what I have told you, I need to traverse the array from the second element. I need to traverse the array from second element, right, till the last element n minus, sorry, I less than n minus 1 and I plus plus. So this will traverse from, right, this will traverse traverse from, right, index 1 to index n minus 2. It will traverse from index 1 to index n minus 2. Because I've written the condition as less than, it will traverse only till here. When the value becomes n minus 1, it will fail and it will come out. So what is the first job here, right? As you find the, right, uh, max height bar on left side. Okay. So the current element is indicated by I value. Current element index is indicated by I value. Okay. So I'll take left is equal to ARR of I. I'll take current element as already the highest. Then I'll write a loop for j is equal to 0, j less than I, j plus plus. Okay. Inside this, what I will do is, see, what are we trying to do here is, I will assume, see, for this element, I will assume left is equal to 1 as largest as of now. Then I will, this is I variable. Now I'll start from the first element and I'll traverse till I. So that is the reason my J for loop is starting from 0 till I. So in this one, I will compare assumed largest, right? Assumed largest is less than ARR of J. Then find out the biggest element, ARR of J. Store that. If the condition is true, store that. Now similarly, right, this will help me to find the right highest bar on the left side. Now I need to find the max height bar on right side. So for that I will assume right is equal to highest is already ARR of I. I will take the current element as the highest already. Then I will traverse the right side. Now right side will start from which element? If the current element is I, right side traversing will start from I plus 1 till the last element. Till the last element. So I need to traverse till there. So j is equal to I plus 1. Sorry. Okay. J is equal to I plus 1. J less than n. J plus plus. So traverse till the last element and find out, right, the highest bar. Right. Okay. That is right. If right is right. If right is less than ARR of J, then right is equal to ARR of J. Finding a biggest value on the right side, finding a biggest value on the left side. Once you get these two, next what we have to do is result is equal to. So once you get these two, what is the next thing? Right? Take the smallest of these two heights. Now take the smallest of these two heights. Take the smallest of these two heights. So how do you decide smallest? Use a ternary operator. If left is smaller than right, if left is smaller than right, question mark, choose the left one, else choose the right one. So whichever is smaller, choose that one based on this condition. Minus current element. Minus current element. This must be added to a variable called as result. So result is equal to result plus left less than right. So choose the smaller one. If condition is true, left is smallest. If condition is false, right is smallest. So it will choose that and subtract the current element, add it to the result variable. Right? Add it to the result variable. So in the third point we have written the difference between smaller height and the current element will give you the amount of water that can be trapped for current element. So like that you repeat it for every element, add all of them, and that will give you the result. That will give you the result. Okay. Once you come out of this loop, return result. That's it. Now as of now, with the values what we have calculated, it was 9. So let's execute and check, is it giving us 9? Yes, it is giving us 9. Are you clear on this example or do you have a doubt? Time complexity of this code is O of n square. Big of n square. That is a reason, right, this will become, right, this logic what we have written, right, is not so much feasible. That is why we, right, we say that this logic what we have written is not so much feasible.